Hey guys, this is my video on how to graph logarithms. If you've never watched one of my videos before, I highly recommend you pause and try the examples when prompted, and there are always free guided notes available at divideandconquermath.com. So a quick review here. This will be very helpful for you if you are trying to graph logarithms. So I would recommend that you just take a second, pause the video, write this in a logarithmic form, write this in exponential form, and then try to find the inverse of this. These are three very relevant questions that come up with graphing logarithms. Hit play when you're ready to see the solution. So for this first one, so the key thing to remember here is that, so in general, y equals log base a of x. This means that a to the y equals x. That's the definition of a logarithm. So if I wanted to write this in logarithmic form, this would be log base 2 of 25 equals, log base 5 of 25 equals 2. That's what I meant to say, sorry. And then for the other one, so this will be 2 to the third equals 8. So just making sure you're good on going back and forth between the two forms. And as you can obviously see, sometimes you can kind of mix it up. So just taking a second to review that is very helpful. And then the other thing is the inverse of this particular function. So to find an inverse, what you do is you switch your x and y coordinates, and then you have to actually solve this. But the problem with this is that you can't actually solve this using a lot of standard mathematical techniques. Instead, what you have to do is you have to go back and reference this definition here. So if I use the definition of a logarithm, then this would be y equals log base 2 of x. And so then I would represent the inverses of y like this, and then just say that this equals log base 2 of x. Okay, so all of that's very relevant for this particular lesson. So now I can actually tell you how do you graph log base 3 of x. So what you want to do is you want to write in exponential form. So I'll just note that, write in exponential form. And so if I rewrite this in its exponential form, this would be x equals 3 to the y. And so now you can probably see why this is so much more helpful this way. So if I have this written in exponential form, I can totally figure this out. It's really hard for me to just plug in numbers for x and to know what these would equal in this logarithm. In fact, for a lot of them, I can't even do it. I can't even evaluate it on my calculator. So if I write this in its exponential form, so we're going to have to change up how we approach the table in this case. So normally when I talk about graphing, I say, oh, choose standard values for x first and then figure it out. But since I can't just plug in things for x, that would kind of make this difficult to determine. I'm going to instead plug in things for y. So what I'm going to do is I'm going to choose these values for y. And then we'll kind of go from there. So maybe you want to pause the video here and just evaluate these, and maybe if you're having trouble reading this, so just to make sure this is nice and clear, this is x equals 3 to the y. So if you want to take a second just to figure these out, you can hit play when you're ready. So if I start plugging these y's into this, so I get the x out, so 3 to the negative second, so remember that's a negative exponent, so that'll actually be 1 over 9, just to kind of show you visually what happened there. That's 3 to the negative second, so I'd write that as 1 over 3 squared, 1 over 3 squared like this, and then this would be 1 over 9. So I'll just erase that real quick. And so now this will be 1 over 3, anything to the 0 power is 1, 3 to the first will be 3, and 3 squared will be 9. Now that we have these points, I would recommend that you pause the video and take a second to graph all these points, and then hit play just when you're ready to connect everything together. It might take you a second to plot this all, so hit play when you're ready. So let's see, so I've got 1/9, negative 2, I've got 1/3, negative 1, I've got 1, 0, I've got 1, 2, 3, 1. So here is my graph. So I just will finish drawing this. Okay, so here's what my logarithm actually looks like. And so as you think about this, so notice that your x values, the x values will never go negative because there's no value you can plug in for the y that will ever make the x's negative. Instead, any negative value that you plug in for the y here will just turn this into a smaller and smaller fraction. So this is kind of the general shape of this, and this is how you would have to figure this out. You have to write it in exponential form or you're not going to be able to graph it. So it's kind of like the big trick to this. Now, while we're talking about this, I want to talk about just inverses here and kind of remind you of something that works with inverses. So I want to just take a second to show you the graphs of log base 3 of x and y equals 3 to the x. I want to show these together. The reason why is because these are inverses of one another, so that's why we did that exercise at the very beginning. So starting with 3 to the x, so here is that graph here. And then if I just lay that next to the other graph, we just did this, right? So there's my log base 3 of x. So I've color coded them just so that you can kind of compare them. So if you have watched any of my other videos on inverses, these have a specific property. I just wanted to take a moment to show you. So inverse functions, when you plot them together, they should always look like reflections over this y equals x line, which is very, very clear actually when you see this. So when we talk about logarithms being inverses of exponential functions, this is like the other big property that kind of comes with this. So we're just kind of convincing ourselves in our mind as to what this actually means. Okay, so far that's kind of what I've got. I've got one more example for you guys. So if you find this helpful, please consider giving my video a like or subscribing to my channel or sharing it with a friend. That really helps me out with putting these free videos on the internet. So I have one more example here if you just want to try it again. So you can pause the video, graph it, and then hit play when you're ready to see the answer. So if I were to convert this into exponential form, so this would be 1/2 to the y equals x. And so once again, what I'm going to do is I'm going to choose my y's first. So I'll choose, let's see, so I wrote that in exponential form. Let me use the white here. So I'll use -2, -1, 0, 1, and 2. So this time when I plug in 1/2 to the -2nd, so just notice that's going to dump the fraction upside down. 2 over 1 is just equal to 2, so this just becomes 2 squared. So that's why this equals 4. This will be 2, this is 1, this is 1/2, and this is 1/4. And now from here, I can go ahead and plot these points. So let's see, I've got 4, 1, 2, 3, 4, -2. I've got 2, -1, I've got 1, 0, I've got 1/2, 1, and then I've got 1/4, 2. So this is going to look like this. So there's the other side of your function. And again, if you kind of know a little bit about exponentials and kind of how the graphs of exponentials look, it's probably not surprising that you have either a graph that will open up like this or like this first one that we did. Those are kind of the two main shapes of these. So that's kind of what you need to know about graphing logarithms. So that will conclude this video. So hopefully it was helpful to you. And I have lots of other videos on logarithms. So hopefully I'll see you in another one. Thanks for watching.